continuing with this chapter, DC circuits, resistors in series and parallel. Then we'll hit Kirchhoff's rules for analyzing circuits that are a little more complex, and capacitors in series and parallel. So let's start out with a couple of review examples. How about something like this? So we're looking to find the current through every resistor. Find an equivalent. Reduce this down to one equivalent resistor. So you start out here, you got a big circuit, right? And you start reducing it down till you get to one equivalent resistor, if you can. Figure out the current there. And then you start building back out until you get back to your original circuit and you know all the currents. So what's the first thing we see? We have two resistors in series out here. Once you get past this junction, all the current that goes through the 2 ohm has to go through the 3 ohm before it gets back to the next junction. So those two are in series, the 2 ohm and the 3 ohm. And what do we do? 12 volts. Okay, now what do? Now you have two that are in parallel, right? Those two have the same voltage across them. They are in parallel with each other. So we can come up with an equivalent resistor for those two. R equivalent 2. And that's 1 over 10. That's a 10. Plus 1 over 5. And what is that? 10/3? A 10 and a 5 in parallel. What do you get for that? Maybe you're used to seeing it this way. It's going to be 3 over 10, right? Okay. Now we have two in series, so we keep going. And our equivalent is 5 plus 10/3, 25/3 of an ohm. Okay, so now we can figure out the current fairly easily, right? This is a 12 volt battery. Actually, let me make this. What should we make this? How about a 25 volt battery? So I can do the math in my head. Make that. Okay, so what we end up with, V equals IR. (25 volts) is going to be I times 25/3 ohms. And that gives us our current in amps. So we get 3 amps in our circuit. Now we start working backwards. So we know that coming out of our battery, 3 amps. So we start working backwards. So what was the last thing we had here? We had a 5 and a 10/3. 5 ohm and a 10/3 ohm resistor. And we know that there are 3 amps coming out of the battery. So what's the voltage drop across each of these resistors? V equals IR for a resistor. So the voltage drop is just I times R, 15 volts across the first one, 10 volts across the second one. You add them up, you have to get 25 volts, right? That's where we're back to the bottom of the battery now, right? So we knew we had to get 25 volts across both of them. So that tells us the voltage here. Now we can split this up into the 2 parallel resistors, and we can figure out how much current goes through each one because we know the R's and we know the V across them.